Okay, problem number 5. Consider the function f of x equals 1 over x squared minus kx, where k is a non-zero constant. The derivative of f is given by f prime of x equals k minus 2x over x squared minus kx squared. So they very nicely took the derivative for us. And then on part A, let k equal 3, so that f of x is equal to 1 over x squared minus 3x. So they just plugged in the k for us. Write an equation for the line tangent to the graph of f at the point whose x-coordinate is 4. So an equation of a tangent line, excuse me, we want y equals mx plus b. I know that my x value is 4. I need to find my m and I need to find my y. I think I'll find my y value first. If the x-coordinate is 4, all we need to do is plug 4 in for our x's in the f of x. So we'll have f of 4 is equal to 1 over 4 squared minus 3 times 4. And that will give us 1 over 4. So my y value is 1/4. So now I just need to find my m. My m is going to be my derivative. So that's going to be y prime. In this case, f prime. And so on this one, they told me what my k is. So my f prime of x will equal k, which is 3. 3 minus 2x over x squared minus 3x squared. And they did tell me my x-coordinate is 4, so now I can go ahead and find f prime of 4. So that will be 3 minus 2 times 4 over 2 squared minus 3 times 4 squared. When I figure that out, it will give me negative 5 on the bottom. I'll get 4 minus 12, which is, okay, hold on, did I do that right? Oh, this is 4, sorry. X was 4. 4 squared, which is 16, minus 12 is 4. 4 squared is 16. So this will be my m. So now I have 1/4 equals negative 5/16 times 4 plus b. If I solve for b, I'll have 1/4 equals, that will reduce to negative 5/4 plus b. I'll add 5/4 to both sides, so b will equal 6/4 or 3/2. So the equation of my tangent line will be y equals m, which we found was negative 5/16 x plus the b, which was 3/2. We could also just keep this in slope point form, which would be just y minus the y value equals m x minus the x value. So both of those choices would be 100% correct. That was worth only 2 points, doggone it. If you found out that the slope was equal to negative 5/16, you got a point. And then if you were able to come up with the correct equation of the tangent line, you also got a point. All right, part B, let k equals 4, so that f of x is equal to 1 over x squared minus 4x. Determine whether f has a relative minimum, a relative maximum, or neither at x equals 2. So first thing we're going to do, we're talking about f prime if we're looking for minimums and maximums, and I'm going to find out what's happening at 2 to see if it's even a critical value. So we're going to find f prime of 2. And if we do this, I'm going to go into f prime. They told me that the k was 4, so it's going to be 4 minus 2 times our x value, which is 2, over 2 squared minus, again, our k value is 4 times 2 squared. So that's going to equal 0 over 16. So my slope is, my derivative is 0 there, so it is a critical value. So we can go ahead and make an f prime chart. And so we'll put, actually, x equals 2 on there. And then I am going to calculate the derivative at 1, and then I'm going to calculate the derivative at, I'm just calculating things on either side. So if I plug 1 into that derivative, I'm going to get 4 minus 2 times 1 over 1 squared minus 4 times 1 squared. I'll get 2 over something positive. 1 plus 4 is 5, 25. So I get a positive value. And then if I plug in 3, I will get 4 minus 2 times 3 over, I don't even have to consider the denominator, because if I square it, I'm going to get a positive answer. And I'll get a negative 2 up top, so this is going to give me a negative answer. So since the derivative is changing from positive to negative, we know that we're going to have a relative maximum. So it says determine whether f has a relative minimum, maximum, or neither at x equals 2. I will say that f has a relative maximum at x equals 2 because f prime changes from positive to negative at that point. All right, and so that was worth, let's see here, that was worth 2 points. If you considered f prime of 2, so you found that f prime of 2 is equal to 0, that would be worth a point. And then if you were able to give your answer with justification, then you got your second point for that one. Okay, part C, find the value of k for which f has a critical point at x equals -5. Well, remember, if it has a critical point, the derivative will equal 0, and we're talking about x equals -5, so I'm going to put -5 in for the x's in the derivative, so I'm going to get k minus 2 times -5 over -5 squared minus k times -5, and that will all be squared. And when I do that, I will get k plus 10 over 25 minus, well, actually that would be plus 5k squared. And then from here, if I would like a critical point at x equals -5, we are going to set the numerator equal to 0. So I'm going to figure out where would that equal 0. And we want to find out where that would equal 0. That would be at k equals -10. And so from there, we know that f has a critical value there. So that was just worth 1 point. Alrighty. And then, oh, that was just worth 1 point. So just one. All right, then on part D, let k equal 6 this time, so that f of x equals 1 over x squared minus 6x. Find the partial fraction decomposition for the function f. All right, so, and then it says to find the integral of f of x dx. So they want us to do the partial fraction decomposition for this. So we're going to have 1 over x squared minus 6x is equal to a over, oops, actually, let's factor that first. Let's factor this in too. We can factor out an x, we'll get x minus 6. So this is going to be a over x plus b over x minus 6. And then if you remember, for partial fraction, we're going to do 1 equals a times x minus 6 plus b times x. And then I'm going to let x equal 6. And when I do that, I'll get 1 equals bx. So b will, sorry, I'll just get 6b. So b will equal 1/6. Okay, and then if I let x equal 0, I'll get 1 equals -6a. So a will equal -1/6. All right, and then from here, so I just need to write the partial fraction decomposition. So the partial fraction decomposition will be -1/6 over x plus 1/6 over x minus 6. Now, if we wanted to do anything with that, we certainly could, but I'm just going to leave it right like that. Okay, and when we did that, that would be worth actually 2 points. So if we came up with that, good for us. And then it actually asks us to find the integral. So we're going to find the integral of -1 over 6 over x plus, I'm going to go ahead and separate it into 2 integrals when we do this. For each of these, the 1/6 is a constant, so I can just pull those out. So -1/6 and then 1 over x. For both of these, they'd be dx's. dx plus 1/6 and then 1 over x minus 6 dx. Both of these are going to be ln, so we'll get -1/6 ln of x plus 1/6 ln x minus 6. And then I'm going to factor out a 1/6. So now I'll have -ln x plus ln of x minus 6, and then we can go one step farther, because since we have, it's going to be this one minus that one, this one's going to go on the bottom, so it's going to be 1/6 ln, big absolute value here, x minus 6 over x, and then plus c. If you were able to find that general derivative, you would get one point, no, 2 points, so plus 2. Okay, so that would be worth 2 points, and there we go.